In our second lecture video on momentum and collisions, we are going to discuss impulse. The impulse is the product of the force applied and the time interval during which the force is applied. This means that impulse is equal to F times t, where F is force and t is time. Another way to think about impulse is that it is just a change in momentum in response to an outside force. So, to change the momentum of an object, a force must be applied over a given time. Since impulse is just a change in momentum, we can say that impulse equals delta p, which represents the change in momentum. This is also equal to the force times time from the last equation. Also, since we know that momentum is equal to the mass times velocity of an object, we can say that all of this is equal to mass times the change in velocity, or m times the final velocity minus m times the initial velocity. We can set any two sides of this equation equal to one another to solve for a missing variable. Before we do any impulse calculations, let's take a look at a conceptual example involving golf. If we have a golf ball sitting on a tee, the golf ball has zero momentum when it's just sitting there because there's no velocity. If an object is not moving, then it doesn't have any momentum. To change the momentum of the ball, the club applies a force for a given time to the ball. In other words, the club applies an impulse or a force for a given time to the ball. The club transfers momentum to the ball because the club was initially moving, so it has an initial momentum. Even though the force the club applies to the ball occurs over a very short time, it still applies an impulse and changes the momentum of the ball. This concludes our brief discussion of impulse and momentum.